Hi guys, welcome back to the next video on C++ programming, and in this we are going to talk about functions. So we are going to cover various topics related to functions in C++, like function overloading, friend functions, call by value, call by reference. Few of these topics you must have already know from C language. However, we are just going to touch upon those points, and we are going to add few more concepts which will be useful in learning C++. So let's begin with the video. So main function is the most important function when you write your C++ programs. This is the first function that is called by the compiler. So if you check here, there are three ways you can write the main function. One is you write int, the return type for the main function, then main, and then parenthesis. So I'm just writing a semicolon over here because we are just talking about the declarations. So this is a standard structure of a main function. I have a return type over here int, then main with the parenthesis, then you have your statements inside of these curly braces, and at the end you have a return 0. Now we are passing 0 over here because the return type of this function main is int. So another way in which you can write your main function is using these two arguments. You must have seen these two arguments when we talk about command line arguments in C programming videos. So I have added that link in the eye icon. You can click if you want to check that. So when you have these arguments, you can supply command line arguments to your program. So this first parameter is number of command line arguments that your program have, and these are the actual command line arguments. So these can be multiple, and you can use those arguments using index of parameter argv. You technically can have a void main instead of int main also, but there are certain conditions wherein your program should not have error, and there are a couple of 3 or 4 points. But I think it's a very good and standard practice that you should always write int main instead of void main. First of all, it's a good practice, and it gives meaning to your function in a way that you always know that your program is going to return something rather than nothing. So you must have observed that in case your program gets an error, so you get additional error on some compilers, that your main function should return a value. On old versions of C, you get a warning, and in some of the compilers wherein in case your program has one error, it will show two errors. Out of that, one will be for the return type of int. But anyways, to simplify things, I'll suggest you to always write int main and then return some value to the compiler, like return 0. Now next is function prototyping. So what is function prototyping? Basically, you declare your function first and then you define your function. So typical form of declaring your function is the return type, then your function name, and then in the parenthesis you have your function's parameter list. So here's one example. I am writing one function declaration as float, which is the return type for the function division, and I'll be supplying two parameters to it. One is float x and other one is int y. Now important thing is that because this is a function declaration, so you can skip writing variable names here. So this is optional, so variable name is optional. So these two are same function declarations, so I have skipped variable names over here. So this is valid, and it's a standard practice to write it like this. And when you make a function call, I have created one float variable. I am naming it as result, and then with the equal to sign, because this division function is returning a float variable. So whatever the value that this function is going to return, it will be stored into results. So these are two parameters I'm supplying. First one is float and another one is int. So there could be some instances wherein your function might not require any arguments to it, or may not require any parameters to it. So in that case, you can write void. You can also write empty parenthesis like we usually write in case of main function. So here it's a function called as display, which is returning me void, as in it's not going to return me anything, and I'm also not passing any values to it. Now in case of function calls, there are two types of call which are usually made. One is call by value and other one is call by reference. So call by value is very straightforward. You have original value passed to a function, and it cannot be modified. As in, when you have, let's say, function add, and you are passing two integer values to it, int x and int y. Whenever, and let's say, suppose you have your function definition over here, and whenever you're going to make a call, let me just add return type also over here as int. So add is a function which is going to return me integer value, and it is going to accept two integer values x and y. So when you're going to make call for this function, let's say 10 and 20, or let's say you have two variables, a is equal to 10 and a equal to 20, b equal to 20, and then here is your call add a comma b. So when this call is made, a and b are going to retain their original copy, and values of a will be copied to x and value of b will be copied to y. So both these variables are maintaining different copies of the same value. So when you pass values like this, the method is called as call by value. Now if you just closely observe, we just have two values, but we are using four variables in this example. So it is a bit of extra overhead that we're carrying, because compiler also has to create two variables whenever this function is called. Okay, so let's say you have 10 calls made to this function, then technically you are going to create 10 multiplied by 2, that is total 20 integers for all those 10 calls. Now there's another method which is called by reference, wherein you can pass a reference to the variables. So assuming this to be a function, so here is my function definition. It's this is return type, and then this is a function name. Now here I am creating a pointer variable, and then another pointer variable, and whenever I'm going to make the call to the function, I'm going to pass address of the local variables. Okay, so in a way these statements are, because this value of x will be referred over here and value of y will be referred over here, so this is nothing but similar to writing x star x is equal to address of x. This address of x is this variable, and similarly star y is equal to address of y. So we know that how to read it. I have given you a technique how to understand use of pointers. So you can just briefly review that video. I have added that link in the I icon. So if you just read it as value at the rate y. So whatever the value that is stored at this location will be replaced over here. Okay, so let us try to understand this with an example. So in case of call by value, let's say I have a class math, and then I have a public function change to which we're just passing single value float. So here is the function definition of function change which belongs to class math. So I'm accepting one float variable, that is y, and then y is equal to 5.5. This is something that I'm setting inside of the function definition. Now inside of main, I'm creating one object m1 for the class math. Then I'm having this local variable float y, initializing it to 3.5. Now if you check what I'm doing over here is I'm calling my public function change. I'm supplying it 3.5 as a value, which is value of y. The function is being called with the help of object m1. So when 3.5 as a value is passed over here, okay, so technically whenever I am writing y is equal to 3.5, so this 3.5 is overwritten by 5.5. okay, so what is happening over here is, because this call is initiated from m1. So m1 dot y is becoming 5.5. Okay, now in the next line I am writing value of variable y. Okay, because y is a local variable over here. Okay, it has nothing to do with value m1 dot y. So the output of this program would still be 3.5 because this call was made with the value. Okay, so 3.5 has as a value has returned over here. Okay, now let us see the similar example in the call by reference. We are going to take example of swapping of two numbers, okay, which is a very popular program, and questions on these are asked couple of times in the programming interviews. So straight away I'm having this function called as swap. So to this function swap, I'm providing two integer pointers. So I'm specifying int address of x and int address of y. So whenever a call is made like this, swap x comma y, so values which are stored into variables, these are which are 10 and 20. So address of these variables will be passed here. Okay, so address of 10 and 20 for the values which are stored into variables x and y. So address of x and y is passed over here. So because these are references, I am creating just temporary variable over here for the swapping. So I am storing value of x into variable temp, and then I'm swapping x with y. So value of y will go into x, and then finally the previous value of x which was stored into temp will be copied into y. So in the first step, so temp will become 10, x will remain as 10, then after execution of next statement x will become 20, temp still is 10, and y is still 20, and in the final statement we are replacing y with value of temp, that is 10, and temp still remains as 10, and x is already changed in the previous statement, that is 20. So if you notice, after execution of the last line, value of x and y have got interchanged. Now important thing that is happening over here is these values are getting changed because we have sent a reference of these variables. So when you just print these values, so it will print 20 over here and 10 over here. So output of this program will be like this. Okay, so important advantage of call by reference is that the compiler doesn't create multiple copies. Even if you have, let's say, 10 calls, only two variables will be created which are only your local copies, and these are just acting as the pointers. So we are just referring to these values directly. So however the operation is being done outside of the local scope, copies new copies of the variables are still not created. So call by reference is very useful when you're working on memory constraint, when you have a good amount of memory constraints, and in case there are multiple calls, even in those cases call by references are found useful. And then we have one interesting topic that is written by reference. So function declaration, you do it with int and then ampersand, then you have your function name. So let's say this as an example, you have int ampersand show and you're just returning num. So by writing this, you are sending reference value of num to the calling function. So inside of main, let's say I am calling show equal to. Now because you are returning reference to this variable, so you can use assignment operator to this function name. So this statement is similar to address of num is equal to 5. Now I'm just writing as this because technically address of n might not give you the correct understanding over here. So we are just going to read address at the address of variable num. Okay, so this 5 value will be stored to the address of variable num. Okay, so again, this is very interesting when you are required to do these kind of operations. So you can use return by reference. So after this, once this statement is executed, when the call is made, okay, and a reference to the variable is received, okay, so this assignment will be performed. And after that, when you write num, you will have value 5. The compiler will print value 5. So here is the output. It will print 5. Then we have inline functions. So inline functions is nothing but that the compiler places copy of code of inline function at each point wherever the function is called. Inline functions are suitable when you have small function definitions. In case you have large function definitions, that will increase your execution time. Important thing about inline function is that in case you have made a call to the larger function, so every time you are making the call, the compiler is going to replace those code lines, and it will increase the execution time for the compiler. So when we write inline functions and whenever we make the call, so it's just a request to the compiler, it's not a command. So compiler might not always do inline function calls inline whenever we're calling them. So let us just try to understand this. When you want inline function to be used, so you just need to write inline as a keyword in front of your return data type. This is your function name then, and then you have the argument list of your function. Then you have your function definition over here. So in this example, what I have done is I have created one inline function with the help of keyword inline. Then I have one return type as int. I'm calling the function as min, that is minimum, and I'm supplying it to variable integer a and b. And in return, I am just comparing these two numbers with the help of conditional operators, and whichever is the smaller value, I am returning that. So either a or b, whichever is the smaller, will be returned. Now inside of main function, if you just take, I have this calls. So this statement, okay, so this statement will be replaced over here by the compiler at the runtime for all these three statements. Now because in this case it is a very small function, so for the compiler the operation would be easier. But in case you have, let's say, large number of statements over here, let's say this function has thousands of lines, so in those cases it's not advisable to have your functions inline. So using functions as inline makes sense only when you have short amount of or small amount of code. Again, as I mentioned in the previous slide, so inline is the request to the compiler. It's not a command. So in a way that is good because compiler will get to know using the function definition that it's a process intensive function. So in those cases he might not replace code lines inline, or the compiler will decide whether to have this function inline or not. That is something that compiler will decide based on the performance requirements. Whichever the compiler finds best, it will do. Either it will convert those lines inline or it won't. So in this example, your output is simply this. It is just going to compare whatever the values that we have supplied, and it is going to print minimum of those values. So in case of 10 and 20, we have printed 10, and in case of 100 and 0, we have printed 0, and in case of 15 and 16, we have got the output as 15. Now let us quickly check about different functions provided in C++, which are under math.h header file. So math library functions which are commonly used are ceil function, that is ceiling. It gives you ceiling value. It rounds provided number n to the smallest integer, and the smallest integer is usually not less than n. So for example, when you supply 5.6 as the value, so ceiling value of 5.6 is 6, and then when you supply minus 5.6, the ceiling value of minus 5.6 would be 5. The similar to ceiling we have floor. Okay, so floor value gives you a rounded value for the variable n to largest integer which would not be greater than n. So just to simplify this, ceiling values are something like this. So this is your ceiling value and this is your floor value. Okay, so your supplied value would be somewhere here. Okay, so when I say 2.1, so ceiling value is 3 and the floor value is 2. Okay, now in case we are talking about the minus or the negative values, so in case of minus 2.1, the floor value and ceiling value would be, the floor value would be minus 3 and ceiling value will be minus 2. Okay, because we are on the other side of the scale. So this is how floor and ceil function would work. We also have other trigonometric functions. So cos x will give you a trigonometric cosine of x. Similarly, we have sin x, which will give you trigonometric value of sine of x. Then we have similarly tan, which will give you trigonometric tangent of x. Similarly, we have exponential value of n, so it will give you e raised to n. Then you have log n, which will give you natural logarithm of n with the base e. Then you have log 10n, which will give you logarithm of n with base 10. And then we have one power function to which we supplied x and y, or two variables. So it gives you x raised to y. Then we have sqrt function, so it gives you square root value of the provided variable. So in case it will give you, in this case it will give you square root of n. And then finally we have absolute value of n, which is given by a function f abs. So abs is basically absolute value. So f abs, when you provide value n to it, it will give you absolute value of variable n. So this line will give you 5, this line will give you 0, and this line, so absolute of minus 5 is 5. So very simple. These libraries make your life quite easy. So these will become quite handy in case you are working on few complex mathematical operations. Then one important topic related to object-oriented programming is friend functions. So there could be instances wherein you might require access to private variables, but the functions which we are going to make call to those private members might not need to be your public member functions. So in that case, what you can do is you can use keyword friend. Okay, then you can have your return type function parameter, function name, and then the parameters list to it. So because you have given friend access to this function print, it can access your private members. Now notice that this is not your member function. Okay, this is open function, okay, which has become friend to your class, and you have given access to this function so that they can access private members of your class. So inside of your friend function, what we are doing is it is receiving one object of type class math, and I'm updating m.weight, which is a data member of your class math. I'm increasing its value with 10. So this statement is nothing but m.weight is equal to m.weight, that is existing value of the weight, plus 10. And once this execution is done, I am returning m.weight. So now let us see what happens when inside of main I'm creating this object and calling this friend function. So I'm passing m over here. So call will be made here. So m.weight will be increased to 10, and this value will be written over here. So 10 will be written over here. Okay, and after that the program will end, and your output of this program would be weight colon 10. So only important thing to notice here is that friend functions need not be your class member functions, but once you give access to an external function by adding friend to it, you give access to your private data members. So in a way, if friend functions are not handled carefully, so that can also become a security issue to your private data members. So friend functions need to be used very carefully. Then we have final concept in this video is function overloading. So function overloading is nothing but the same function name but with different parameters or return types. So if you just check this example, I have three variables ABC of type integer. Then I have two function names which are both same. I'm calling both as add, but if you just notice, the first function is accepting two variables of type integer while other one is accepting three variables of type integer. Now this is the concept of your polymorphism, that is it gives different meaning to the same things. So in this case we have same function name, but depending on your function calls, in case I am passing two variables or three variables, the appropriate function will be called. So if you check this function definition of both the function, I'm just returning a plus b over here when two variables are supplied, and in the other function when three variables are supplied, I'm returning a plus b plus c. So inside of main function, when I'm just updating value of object m1 which is created over here, so I'm updating value of variables abc with 10, 20 and 30 respectively. So if you just check over here in the next statement, I'm making call to function add. Here I'm passing two variables, so call to this function will be made. So this will return me addition of 10 and 20 is 30. And in the next statement, what is going to happen is that it is call will be made to this function, and it is going to print addition of 10 and 20 and 30 is 60. Okay, and your function will end over here. Now see, just important thing to remember over is that your function can have different parameters and different return types, and depending on the call, the compiler will decide which function to be called. With this, you can add a wide range of function variations in your class. You can extend this class by adding functions which can have two float values, or you can also have add and you can pass two character strings which will concatenate those supplied strings and send you a single string. So that is how you can have single function name, but depending on your parameter list or return type, you can have different copies of functions. Guys, in case you have any suggestions or comments, definitely share that from the comment box given below. We'll definitely try to improve or try to accommodate those points or your suggestion in the upcoming videos. So that is all for this video, guys. Don't forget to like this video and don't forget to hit the bell icon so you get the instant notification whenever we upload any video. Share this video with your friends and family, so that will really encourage us to come up with the more videos. Thank you so much for watching, guys. I'll see you in the next video.